Hey kids, it's me again, Teacher A. So this is our lecture video for the week. Here are the topics that we're going to have for today. Okay? So last time, if you recall, one of the assumptions that we had is the payment period is the same as the interest conversion period. In this lecture video, we're going to have the case where payment period is not the same as the interest conversion period. Okay? PP and ICP differ, but payment amounts are still level. Okay? So pare-pareho pa rin ang amount of payments for a certain period of time. Okay, so how do we solve this kind of problem? How do we solve annuities payable at a different frequency than interest is convertible? So actually, we have two approaches or two methods. So the first method is you make the payment period and the interest conversion period the same. How? You convert the given interest rate the same frequency as the payments are made. Okay? Let me give you an example. For example, the payment period is every quarter. Okay? While the interest conversion period is every month. Okay? So you try to convert the I upper 12, for example, that's the nominal rate of interest, convertible monthly. You try to convert it to I upper 4. Okay? Para maging kapareho siya ng payment period frequency. And that is quarterly. Right? So, method 1 is easy to use because we were able to establish relationships among different measures of interest, right? Okay, what is the second method? Here, we are going to develop expressions using annuity symbols. What are those annuity symbols? Our A angle N, S angle N, A double dot angle N, S double dot angle N, A angle infinity, and A double dot angle infinity. Right? So here, sabi dito, we don't need to convert the given interest rate. Okay? So if you're planning to take SOA exams, Society of Actuaries exam, or exam FM, Financial Mathematics in particular, okay, you will survive exam FM by just using the first method. Okay? So, ito yung mas madali kasing gamitin and it is okay to just use this in taking SOA exams and even in our exam. So, why do we need to discuss the second method? Well, for actuarial symbols' sake, meron kasi tayong mga actuarial symbols na mamamit in the discussion of the second method. Okay? Para pag nakita nyo siya or na-meet nyo siya sometime in the future, alam nyo kung ano yung symbol na yon. Here's the problem. We have to find the accumulated value at the end of 4 years of this investment. 100 is invested at the beginning of each quarter for the first 2 years, and 200 is deposited at the beginning of each quarter for the next 2 years. Given I upper 12 equals 12%. It's very clear that PP is not equal to ICP, right? Let me show you the timeline. Okay, this is the first year. Okay, and payments of 100 is made at the beginning of each quarter. Okay, so this is the beginning of the first quarter. second quarter, beginning of the second quarter, and so on. Okay? For the first 2 years. Well, for the last 2 years, the amount of deposits is equal to 200. Okay? Same. Deposits are made at the beginning of each quarter. Right? And we have I upper 12 equals 12%. Okay. According to the first method, we have to make PP equals ICP. How are we going to do that? We're going to convert I upper 12 to I upper 4. We're going to find the effective rate of interest per quarter. So that is, we're looking for I upper 4 over 4. Okay, so you recall your identities on different measures of interest. And ito ang gagamitin natin. Okay? Okay, so substituting I upper 12 equals 12%, we're going to have that. Your effective rate of interest per quarter is equal to that one. Okay, let's call it J. Okay, para hindi naman masyadong hassle isulat ang I upper 4 over 4. Let's just call it J. Okay, so magkapareho na, di ba? PP is now the same as ICP. So you just recall your basic annuities. Okay, so to imagine that better, let's have the original timeline here, and I'm going to make use again of the red timeline. Okay, what did I do here? I relabel again the times. Okay, parang my time 1 now is the first quarter here. Eto. Okay, and so on. And we know that there are 16 quarters in 4 years. So that's why I have 16 here. Okay, so we need to get the accumulated value of this annuity. So let's have T equals 16 as our valuation date. Okay, so ano kaya ang accumulated value? So first, you disregard these payments of 200. Okay, ignore them. Okay, let's just focus first with these payments of 100. Okay, remember, it is an annuity due, right? So to accumulate this, you have 100 times S double that angle 8, right? 100 times S angle, 100 times S double that angle 8. But that one is, that value falls at T equals 8. Dito pa lang yun. Right? This is where you find your 100 times S double that angle 8. You have to carry this value to time 16. How are you going to do that? You carry a single amount here to time 16. So you multiply it by 1 plus J raised to ilang periods ang dinaanan niya dito. 1 plus J raised to 8. So that's why we have this. Okay? Now, we evaluate naman, or we get the accumulated value of payments of 200. Again, this is an annuity due. So if you get the accumulated value, that is 200 times S double that angle 8. Okay? And that value falls here at T equals 16. Okay? Okay, so that's why we have this one. Okay? Kung hindi kaya, pwede nyo rin putulin ang timeline na ito. Like you consider this timeline first from 0 to 8, but you don't include 200. Okay? And then you try to draw another timeline for the payments of 200. You make it times 0. Yeah, this is times 0. This is times 7. And this is times 8. Okay? So you may do that. All right, so how are we going to get the numerical value of this? So you recall S double that angle 8 using J as the effective rate of interest, it is equal to this. 1 plus J raised to 8 minus 1 all over D. And don't forget, D is equal to J divided by 1 plus J. What is J? Yung kinumpute natin kanina. Your I upper 4 over 4. Okay? Using your calculator, you will get that value. So now, let's discuss how method 2 works. Okay, so it's more on formulas. Okay, so let's derive formulas. So annuities payable at a different frequency than interest is convertible has two cases. This is the first case. Annuities payable less frequently than interest is convertible. Okay, so you may just think of PP is less than ICP, right? Payment period is less than the interest conversion period. Okay, let's consider this example para mas ma-imagine ninyo. Okay, consider payments of 10 at the end of each year for 5 years. Find the present value of this annuity using I upper 4 equal to 8%. Okay, what is the payment period? The payment period is every year, while the interest conversion period is every quarter. So do you see? PP is less than ICP. Okay, less frequent. Or mas madalas yung interest conversion period. Alright? Okay, so let us define some variables here. Okay? Actually, hindi naman natin isolve ang example number 2. For demonstration purposes lang siya. Okay? Let's have K. Okay? So, K is the number of interest conversion period in one payment period. Okay. Going back to our example number 2. What do you think is the value of K? So it's like, how many quarters are there in 1 year? It's clearly 4. Right? So that's K. Ilang interest conversion period in one payment period? Okay. Let's now have N. What is N? It's the term of the annuity measured in ICP. So, ibig sabihin nito, gaano katagal yung payments. Okay? Pero, using ICP. So, what is our interest conversion here in example number 2? In terms of quarters. Okay? So, parang, how many quarters are there in 5 years? Kasi hanggang 5 taon lamang ang annuity natin. So, we know that there are 20 quarters in 5 years. So, that's it. N is equal to 20. Okay? Next. J. J is the effective rate of interest per interest conversion period. So, what is J? Your J is your I upper 4 over 4. So, you just divide 8% by 4. And then you will get 2%. Okay? So, that's the effective rate of interest per interest conversion period or per quarter. Okay? And then finally, how do we count the number of payments? So sabi dito, n divided by k. So what is n divided by k? 20 divided by 4. What do you get? 5. Okay? So 5 nga lang ba ang number of payments natin? So you go back to our example. Okay? Consider payments of 10 at the end of each year for 5 years. Check. Yeah? It's very clear that there are 5 payments of 10. Right? So that's why to count the number of annuity payments, all you have to do is divide n by k. Okay? Let's derive formulas now. So let's consider an annuity immediate. So here's the timeline for an annuity immediate where PP is less than ICP. Okay? So you can see, this is the term of the annuity. Ganito katahaba ang annuity. It's up to N. This one is in terms of ICP. So merong N interest conversion period. Okay? Tapos ito, yan, I labeled it K, 2K, 3K, and so on. This is N minus K. Why? Because yung unang payment period will happen after K interest conversion periods. In one PP, there are K ICPs. So after K ICPs or interest conversion periods pa, saka pa magkakaroon ng unang payment. Okay? Tandaan nyo, more frequent ang ICP than the payment period. Okay? So this is the timeline for an annuity immediate. We're going to evaluate its present value and its accumulated value. How are you going to get the present value? Diba? All you have to do is to carry all these values to times 0. So for example, itong unang 1 na to. How are you going to carry it to times 0? You multiply it by V to the K. Okay? The second payment of 1, you multiply it by V to the 2K to be able to carry it to times 0. And so on. So that's why, to get the present value of an annuity immediate, we have that one. Wala tayo masyadong bagong gagawin sa derivation ng present value and accumulated value dito. Okay? Kapareho lang siya nung mga videos natin last week. Okay? Okay, so you notice this is just a geometric series. Okay, applying the geometric series formula, you'll have that. This is the first term. What is the common ratio? It's V to the K. And then how many terms are there? Ilang payments ito? It's N over K, right? All over 1 minus R. Yeah? And then if you simplify, ginawa na natin yan last week. Okay? You're going to have this. To simplify further, let's multiply both the numerator and the denominator by 1 over J. So 1 minus V to the N over J, this is simply your A angle N. Right? And then 1 plus J raised to K minus 1 all over J, that is exactly your S angle K. That's why you have that. When you see this symbol, a quotient of A angle N and S angle K, you interpret this as the present value of an annuity immediate where payments are made less frequently than interest is convertible. Okay? PP is less than ICP. Alright? So how do we get the accumulated value? So we evaluate or we use T equals N as our valuation date. Yeah? Pero hindi natin ito iisa-isahin to get the accumulated value. You recall, if we know the present value of an annuity, we can easily get its accumulated value. Kasi you imagine this value is a time 0. How are you going to carry it to time n? You see? So you just use the accumulation factor. What are you going to multiply to A angle N over S angle K? It is simply 1 plus J raised to N. Right? You see? Whatever the value of the present value, you multiply it by 1 plus J raised to N. That's how you carry the present value to time N. Okay? That's it. And what is A angle N times 1 plus J raised to N? It's like a basic annuity immediate. Do you recall? A basic annuity immediate. You have to carry this to time N. So that is exactly your S angle N. That's why you have this. For the accumulated value of an annuity immediate where PP is less than ICP. Now let's have an annuity due. Same case. PP is less than ICP. This is the timeline. Okay? The first payment is made at time 0. The last payment is made at time N minus K. Okay? Let's get its present value. Ganun lang then, you have to carry everything to time 0. So what do you have? 1 plus V to the K, right? Plus V to the 2K. What is the last term? It is 1 times V to the N minus K. That's why we have that one. And it's again a geometric series. So you recall the geometric series formula and you're going to have that one. Okay? And then same, you multiply both the numerator and the denominator by 1 over J. And then if you inspect closely, the numerator is exactly your A angle N, while the denominator is exactly your A angle K. Okay? So if you see this expression, this is exactly the present value of an annuity due where payments are less frequently than interest is convertible. All right? Okay. So I'm not going to, derive the formula for the accumulated value of an annuity due. Okay, all you have to do is to multiply this by 1 plus I or 1 plus J raised to N. What will happen? If you multiply this by 1 plus J raised to N, it will become S angle N over A angle K. Okay, let's recall example 1. Okay, I just recall the timeline here. Okay, sige nga. In our previous example, what is K? Okay, again, what is K ba? The number of interest conversion period in one payment period. Okay, the payment period here is quarterly, while the interest conversion period is monthly. So it's like To find K, you ask how many months are there in a quarter. So there are 3 months in one quarter, right? What about N? N is the term of the annuity, meaning gaano kahaba yung annuity or yung series of payments. Dito, ang gagawin ko, since nagbago yung payments, I'm going to cut it into 2 timelines. Like, I'm going to consider the first 2 years. Okay? Ito yung unang taon. Unang 2 taon. Okay? And then the other timeline, yung last 2 years. Okay? So that's why I'm just going to consider N as 2 years. So what is N in terms of ICP? So it's like, how many months are there in 2 years? 24. Right? So 24 months for my first timeline. And then another 24 months for the second timeline. Okay? What is J? Okay, we're given I upper 12 equals 12%. So all you have to do is to divide it by 12, and then you will get 0.01 or 1%. Okay, so here we are going to use the second method, meaning we are not going to convert the interest rate. Okay, kita nyo naman, wala akong ginawang interest conversion. I will make use of I upper 12 over 12. I will not convert it to I upper 4 over 4 para lang magpareho sa payment period. No, I'm not going to do that. Okay, let's make use of method 2. With these values, we are going to get the accumulated value of this annuity. Obviously, it is an annuity due. Okay, so let's recall the formula on how to get the accumulated value of an annuity due where PP is less than ICP. Diba? Ito yung present value. Anong gagawin natin dito? You multiply it by 1 plus J raised to N. So it becomes S angle N over A angle K. So that's the accumulated value of an annuity due. So now, accumulated value is equal to, for the first set of payments of 100. So that will be 100 times, what is the accumulated value of an annuity due where PP is less than ICP? S angle N over A angle K. So that's why we have this one. Yeah? S angle 24 over A angle 3. Okay? For the first 2 years only. Okay? And this value can be found at this point. Okay? Diyan. Dito. So we need to carry it to time 4. Okay? So what are you going to multiply? You're going to multiply it by 1 plus J raised to what? Ilang months ang dadaanan niya bago siya makarating dito? 24. Okay? So that's the value of this annuity, yung first set of annuity natin. Okay? What about the second set of annuity? Okay? Yung payments of 200. Again, this is an annuity due. So the value of this 200 at this point is equal to 200 S angle 24 over A angle 3. Okay? And you know what? Doing the math using your calculator, you will get the same value as we computed kanina. Diba? So, kayo na ang bahalang mag-judge kung alin ang mas madali. The first method, what is the first method? You convert the interest rate the same frequency as the payment is made. Or, the second method, you try to write everything in terms of actuarial symbols, but there's no need to convert interest rates. Let's have perpetuities now. Same case, PP is less than ICP. So madali na ito, no? Because all you have to do is to get the limit of all the formulas that we derived as n approaches infinity. Okay, for example, for a perpetuity immediate, to get its present value, you just recall the formula for an annuity immediate. Ito yon. And then just get the limit as n approaches infinity. And you will get 1 over j times s angle k. Okay? Because ito naman, constant lang naman siya. Alright? Okay, same goes with perpetuity due. Okay? Just get the limit as n approaches infinity of the present value of our annuity due. And you will get this.